Hey everybody, on to 7.6b, graphing exponential functions, and our objective is to graph exponential functions. So here's how to do it. All right, to graph an exponential function, we used to do this by hand, but things are slightly and slowly changing. You're still going to go through this process pretty much, though. You're going to choose several values of x. You're going to pick your own inputs. Okay, you want to use positives. You want to use some negatives, and you want to use zero. Now, every exponential function will be a little bit different, so you might not end up using positives. You may not end up using negatives, but towards the beginning, choose some of each, so we have some on each side of our y-axis. All right, you're going to plug them in. You're going to evaluate the function, and then you're going to create ordered pairs. You're then going to plot those ordered pairs, and then you're going to connect them. All right, but these are not linear, so you need to connect them with a smooth curve. Yeah, smooth curve, meaning you want to make it not jagged. You want to just go as smooth as you can. Okay, so let's graph this one. Okay, so let's pretend we're going to graph y equals 0.5 times 2 to the x. So the first x I'm going to pick, and I would strongly suggest, is always pick -1. What I'm going to do is I'm going to plug -1 in for x, 2 to the -1/2. I'm sorry, 2 to the -1, I'll kind of give the answer. It gives me 1/2 times a half gives me 0.25. So when my input is -1, my output is 0.25. Pick my next one, 0. 0 is always a great one because what's 2 to the 0 power? It's anything to 0 power. We learned that last second. It is 1. So then it's 2 to the first gives me 0 times 0.5 gives me 0.5. So the next ordered pair would be 0, 0.5. They're kind of hard to graph. So the ordered pairs sometimes you create may not be helpful. That's the way it goes. Plug in 1, I get an output of 1. I plug in 2, I get an output of 2. All right. Once I plot those points, I would get a graph that looks like something like this. All right. Now, the more points you generate, the more of the curve you'll be able to see. But this is what an exponential function will look like. It starts off really, really close, and then it just starts increasing, and then it's increasing more and more as time goes on. Okay. So let's go through this one. I'll go through this whole process. Let's graph y equals 2 to the x. My first input I want to pick is -1. I plug -1 in there. 2 to the negative first power is, hopefully you got 1/2, 0.5. I want to put 0.5 here. It's easier for me. So what I'm going to do now is I'm going to plot that point. I'm going to go to where -1/2 is. I'm sorry, -1, and I'm going to go up to a half. That's that point. Check. I'm going to do my next one. 0. When I plug 0 in, 2 to the 0 is going to be 1. Remember, anything in the 0 power is going to be 1. This has a starting value of 1 because there's nothing out in front of there. It would be 1 times that if I really wanted to put something there. My next number I'm going to pick, guess what it is? It's 1. Not going to trick you. 2 to the first power gives you 2. So my next point would be over 1 up 2. And my last point for now, I could keep going. I plug in 2. 2 to the second is 4. So my next order pair would be 2, 4. So notice my x's are increasing by 1, but my y values are doubling. So the next one, see how this jumped up 1, this one jumped up 2, the next one would jump up 4. So if I go 3 and then up 1, 2, 3, 4, I know this would be my next point. This is up at 8. If I did another point and made a 3 here, what is 2 to the third power? It is 8. And now what I would do, this is not going to be smooth because I'm using a mouse here, everybody. What I would do, though, is I would do my best to make a smooth curve. I would draw arrows, and I have to extend this. Now, this never, oh boy, that went up. This never goes below the x-axis. You can't get to 0. All right, you cannot get to 0 going that way. So there's my beautiful looking graph. Let's try one more here. Here I have a starting value of -1/4 times 2 to the x. My first input is -1. I'm going to go through a little quicker here. I did all the math. When I plug -1 in there, I get -1/8, which is -0.125. That's almost nearly impossible to graph. I can't even, no, I'm not graphing that point. All right, let's go to the next one. 0, if I plug 0 in, 2 to the 0 is 1, times that gives me -1/4. That's even hard to graph. What if I go up to 1? I plug 1 in, I get negative a half. So that's probably the first point I can pretty much graph. When x is at 1, y is at negative a half. All right. I'm going to keep going. When x is 2, I plug 2 in there. I have negative 1. So over 2, down 1. My next point I have, that's a dot. I want that dot there. My next point, x value is 3. Plug that in. I get negative 2. So over 3, down 2. And now I'm starting to see the pattern here. Well, the pattern is continually doubling. And the reason it's doubling is because my base here is 2. But if I plug 4 in, I get negative 4. So negative, if I go over to 4, I go 1, 2, 3, 4. And here I have my graph. All right. And I would probably maybe even want to go one more. If I go to 5, I know that's just going to be negative 8. That looks like an S. I know, but it's a 5. So I'm going to go down 5, 6, 7, 8. Here I go. So now I can tell this exponential function is actually going downward. It's negative, but I also have to extend it in this direction. All right. Now, the reason it's going downward and negative is because of this thing right here. All right. This negative 1/4. So this page will tell you all about what the functions will look like and what type of graph they will make. These two on the left side, this is when a is greater than 0. I'm sorry, I misspoke. When a is greater than 0, your starting amount is greater than 0, your graph will be above the x-axis. When your starting value a is less than 0, it will go below. Now, if you look here, these two, this is when b, your base, is bigger than 1. It'll be starting close to 0 and then either getting further away, it will be then getting further away, and vice versa for here. All right. I'm going to suggest pausing. Well, I'll make a note to pause here, absorb this information, and you can grab that. Okay. Last thing I want to go over here is let's match a graph. I want to go a little bit more in depth here. Here's the function. What graph matches that? And this is nice. You don't actually have to graph it, but we got to figure out which one is that. And this one actually at the end, I like this example that I picked. Pat myself on the back. Has a y-intercept. It's like this -1. That tells me it has a y-intercept of -1. All right, that's what we can think of. Now it's not actually a y-intercept though. All right, that's the lowest point it can get to is -1 on the y. That's like the where it will never get to there. Okay, so do you see how this one has it is at y equals 1, this line? So I know it's not that, and I know it's not that. All right, it has to be one of these two. So now this is where that last slide might come in handy. This is positive, this is big. So which one of those would it be? Would it be this graph, this one, or this one? Which one would it be? Which one will it be? Is b bigger than 0? And is a bigger than 0? Yeah, so that is going to be our choice. So we don't even need to really plug numbers in, but that's one way we can choose which graph matches it, is by using this page and this information. Okay, the work for this is going to be a little different. I'm trying a new site. It's called Adia? I don't know. But what it is gives you 4 graphs. You got to match it to the equation, or vice versa. You got to get 4 correct. And once you're done, I'm pretty sure it'll say, way to go, or congrats, or you're done. After that, you can do your mastery check.